Welcome to solverfy.
All right, so problem number 22 wants us to calculate the wavelength of photons that are produced during a proton-antiproton annihilation. So what it states is that the proton and antiproton are at rest. So their momentum is equal to 0. So therefore, one thing that we need to state is that the momentum before, the momentum of the total momentum of the photons must also equal to 0. So that just means that they're going to come off with momentas that are equal in magnitude but opposite in direction, which means that since the momentum of gamma 1 must equal to the momentum of gamma 2, the magnitude of the momentum, that means that the energy gamma 1 must also equal to the energy of gamma 2. So just for purposes of conservation of momentum and energy, so these must equal to the total energy of the combined rest mass of the pion, the proton and antiproton pair. So putting that mathematically, so we have the proton plus the antiproton rest mass energy pair. So since the mass is the same of both, it's just equal to m mass, I'll just put that as 0. C squared is going to be equal to 2 times the energy, the photons of each photon. So each photon has to have energy equal to one of them. So the photon pair, I should state that the photon pair has to have energy equal to the rest mass of the proton-antiproton pair. So this is going to be equal to 2h, because the frequency is just the speed of light, divided by its wavelength. So now we can solve for the wavelength, get rid of the 2's, and state that lambda is equal to hc over m0c squared. Now I'm not going to cancel these out because this keeps it in units of the rest mass for simplicity for solving this. So we have 6.626 times 10 to the minus 34 joule seconds times the speed of light, 3.00 times 10 to the 8th meters per second, divided by the rest mass of a proton-antiproton, so 938.3 times 10 to the 6th electron volts, and then since we're using units of joules, we're going to convert this to joules, 1.60 times 10 minus 19 joules per electron volt. So this gives us that the wavelength of each photon must be 1.32 times 10 to the minus 15 meters, or 1.32 femtometers.